Perpetuity costs 77.1 and makes end of year payments. It pays 1 at the end of year 2, 2 at the end of year 3, so on, n at the end of year n plus 1, and then they level off. So we have to find n. Now, these first n payments, they are an arithmetic annuity, and the first payment is 1, and the increment in each payment is 1 because the first payment is 1, second is 2, third is 3. So remember, in the arithmetic annuity, P is the first payment, which in this case is 1. Q is the increment, which is also 1. So this is not quite a regular annuity because a regular annuity we know is either starting at time 1 or at time 0. This is like a deferred one because the first payment is happening neither at 0 nor at time 1, but it's happening at time 2. So if we treat this as an arithmetic annuity immediate, these first 10 payments, then equation 98.1, which was PAN plus QAN minus N nu N over I. So let me show you. 98.1 was this equation. So that gives us the present value of an arithmetic annuity immediate. So if we use this one, then it will give the value of these first 10 payments at time 1, because the first payment is happening at time 2. And we know that the annuity immediate formula gives the value 1 period before the first payment. So if the first payment is happening at time 2, then the value at time 1 of these first 10 payments will be PAN. P is 1, so we just see AN, and then Q times all this, AN minus N nu N over I, and Q is also 1. And therefore, the present value of the first n payments is found by multiplying all this formula by mu, which is 1 over 1 plus I. So that way we are bringing the value from time 1 to time 0 by multiplying by 1 over 1 plus I, or mu. So when you distribute the mu, you get the present value of the first 10 payments as mu AN plus mu AN minus N nu N plus 1. See, this mu is just multiplying here and then here and then here. So when it multiplies here, this power becomes N plus 1. And the payments are then constantly N after time N plus 1. That is starting at time N plus 2. So this after is the key word. They say in the problem that after time N plus 1, the payments become constant at N. So the first time after N plus 1 is time N plus 2. So these constant payments are now regular perpetuity, and therefore the equation for a regular perpetuity, 45.3, you can review lesson 45 if you need any review on that. And that gives the value of these payments 1 period before the first of these, because equation 5.3 was about a perpetuity immediate. And that equation said that the present value of perpetuity immediate is first payment divided by I. So now remember, we are dealing with the payments once they level off at time n. And the first of these is at time n plus 2. So the perpetuity immediate formula will give their value 1 period before the first payment. So therefore it will give it time n plus 1. Because n plus 1 is the 1 period before the n plus 2. And so the present value of these constant payments, bringing it from time n plus 1 to time 0, we multiply this one by nu to the n plus 1, in fact, because this value is sitting, this n over I is sitting at time n plus 1, and we need to bring it to 0, so we multiply it by a factor of nu to the n plus 1. So that will be the present value of the constant part of this annuity. And The overall present value, which is given to be 77.1, should be the sum of 1 and 2, because 1 was the sum of the arithmetic part, the first 10 payments, and then 2 gave us the value of the remaining payments. And the sum of the two will give us the overall present value, which is 77.1. So that will equal to this expression, mu an plus mu n minus n mu n plus 1 over I, and then plus this one, n over I mu n plus 1. And now when we factor out a new an, so you see this first term over here will be mu an over I. And we have a new an over here. So if you factor a mu an from this term and this term leaves you a 1, and this term leaves you a 1 over I. So we have dealt with this one and this one, and then this one we just write as it is, minus n mu n plus 1 over I, and then this one we write as it is, plus n over I mu n plus 1, and you can see that this term is actually the same as this term, so these two cancel out. And then over here, the mu is 1 over 1 plus I, an is just an, and then this one we make a common denominator. It's this one simplifies to I plus 1 over I. And these two, like we said, have canceled out. And now this I plus 1 is the same as this 1 plus I, so they cancel out and they leave us with an over I. And now the left-hand side was 77.1. So 77.1 is equal to an over I was 10.5%, so 0.105. And so multiply both sides by 0.105 and comes out to be this. And now in the financial calculator, if you put the present value as negative 8.0955, the PMT as 1, and I as 10.5%, we get n is equal to 19, or you can also do it algebraically by writing an is equal to 1 minus mu n over I. And the correct answer is C, n was 19.